everyone. Today I'll be performing paired samples t-test. The null hypothesis is granting pay raise to workers does not contribute to work productivity. In other words, pay raises does not have any effect on workers' productivity. The alternative hypothesis is that granting pay raise to workers does have impact on work productivity. With the alternative hypothesis, we seek to reject the null hypothesis that giving pay raise to workers does not contribute to work productivity. We would like to we would like to claim otherwise. And in order to do that, and in order to test our claim, we will need to do what we call in the statistics a paired samples t-test. A paired samples t-test is when you're looking at two paired samples or two fields of data which comes from the same population. One of the field or one of the columns of or one of the variables of the data is before you introduce a change, and the second one is after you introduce a change. So we have a data set of two we have a data set um, of two productivity measures, which is the number of chairs manufactured by each worker in a factory. And so one of the variable is before we introduce a pay raise, we check how many chairs do workers manufacture on average. And the second one is the number of chairs that are manufactured by workers on a monthly, on average, after we introduce the pay raise. So these are the two pairs of variables that we would like to test today. So the first thing is we will need to assign the level of alpha significance level that will be 0.05 because this is a social science related statistical test. 0.05 is a standard cutoff. First, we will import the file from the destination that we have assigned in our case, and also make sure, depending on the type of worksheet or data source that you have, make sure you have the library on in order for R to be able to read that file. So we already imported the file, the data set. So we would it's a good practice to use attach in order to attach or in order to attach the name of the variable so that every time we call in the field of a variable, we don't have to put the name of the variable first. In other words, when we let's say when we would like to, let's say, get the mean or the average of, let's say, before um, the number of chairs manufactured per month, we can what if we activate if we call in the attach command, we don't have to write the name of the variable, which is productivity, every time, and then dollar sign and the name of the field. We can simply type in the name of the field because R already knows what variable to call in the field from. A couple of important things about the paired sample test is that the assumptions are that it is randomly selected samples. It's SRS. In other words, these 50 people that we went out and collected survey data from, we have to that these data, the pair sample test assumes that these data are randomly selected. In other words, everyone in this survey had an equal chance of being selected for the survey. The second assumption is that they're independent samples. It means that they were taken at two different times. The third, excuse me, this is wrong. So they're paired or dependent groups. In other words, they are one is dependent on the other. They're paired. One what represents before the introduction of an effect. The second one represents after the introduction of the effect. And lastly, the test assumes that it's normally distributed. It's very important that we make sure that both of these fields both of these fields or variables within the subvariables are actually normally distributed. If they're not normally distributed, then t-test as a parametric test is not the ideal test to perform. Then we will, and instead of looking at the mean difference of the mean, we can look at the difference of the median. And there are other tests for those, which I'll produce separate videos about them. One of the ways we can look at the normality of the variable is through histogram. It's not very highly abnormal or skewed before the manufacturer chose before introduction of pay raise, and then after this is also not so bad. So it's and also because our sample number sample are not very small, we give it we consider that it's a normally distributed variable. The variables are normally distributed. We'll move on to the mean. So uh, before we introduced the pay raise, before we give all the workers a pay raise, on average they produce 9.84 chairs on a monthly basis. And once we introduced the pay raise, it went up to 12.9. That means on average, people produce almost three chairs more than when they were when they were not paid a pay raise. So we see that there's a difference in their averages, and there's a difference in the production of the chairs. But what the pair sample test does is it tests whether this change is statistically significant. Is this the result of a random chance? Is it the result of an accident, or is this something statistically significant that we can actually accept it as something significant to generalize it to a more the knowledge of or as accepted knowledge about the relationship between pay raises and the relationship between pay raises and productivity. So we can the t-test is pretty much the same. We put the first variable x, which is before the introduction of the effect, and then the second variable will be after the production of the effect. So both of the fields come here. These are the two fields from here. And the third one is we make sure that we we add that it's a pair test so that R knows that that it's performing a paired sample test. So we run the script and bingo, we get the result. So our cutoff point was 0.05. So the first piece of information, the most important information is that the p-value is below 0.05. And with degree of freedom of 49, degree of freedom is pretty much a number of rows or the number of records, a number of data points within that data set. Mine, it's 49, it's 50 here. The reason it's 49 here is because this is sample. So it's when you were dealing with sample, it's n minus one. So it's 50 minus one, which is 49, and this is our t value. So as R also projected, the true mean and difference is not equal to zero. In other words, the average is not equal. It means that there is actually a significant amount of difference between the two, and difference is minus three or plus three. That means every that it's statistically significant to claim that pay raises at three chairs, production of three additional chairs after it's introduced to as an effect to the workforce. So we write the conclusion paragraph here. The paired sample C test degree of freedom is 49. t-test is 4.49, 4.18 minus 4, and p-value is below 0.05, revealed that there is statistically significant difference between the productivity measures before and after applying pay raise. Therefore, therefore we can reject Therefore, we can reject the null hypothesis in favor of the claim that pay raises can significantly contribute to the productivity of workers. In our study, the workers on average produced 9.84 chairs monthly before the pay raise. This productivity change to average of 12.9 after the pay raise was applied. Lastly, this difference is generalizable. So um, in a nutshell, our pair samples t-test revealed that that uh, it is statistically significant to claim we can reject or we can accept the hypothesis that granting pay raise or giving pay raise to workers actually does impact their overall productivity. I hope this video was helpful. Thank you very much.